to really look at how can we tackle those challenges of reproducibility. So Prof is from the University of Chicago. He's currently the Associate Vice President for Research Computing and Founding Director of the Research Computing Center at the University of Chicago. And I know he's been, a friend of NICIS, and the CHPC, and we are hoping to continue that friendship. He's also the former director of the Scientific Computing and Applications at the University of Minnesota, as well as the co-chair of the U.S. National Science Foundation Advisory Committee on Cyber Infrastructure, as well as a member of the National Council of Science and Technology. So let me take this opportunity to welcome you, Prof, and we are looking forward to your presentation. Thank you.
Thank you so much. Good morning. Before I can start, it's always a great pleasure for me to be here. I was about a week ago at Supercomputing Conference when I was speaking with Dr. Sitole, where I said it's usually the last big meeting at the end of the year. There's no way I will going to miss it. I just went back home to Thanksgiving, and the next day I was on my plane for South Africa. And it's also an opportunity for me to say thank you for the CHPC family and to Dr. Sitole for the introduction. I just can't believe it's already 18 years. It was like it was yesterday. But when you see the journey and the accomplishment, it's something really to applaud. The topic I'm going to talk about today is something really dear to me. And I was actually, when I was sending my abstract, I just realized it's been now almost actually 30 years since my first day I used a Cray YMP, starting doing supercomputing. But the one thing I keep on realizing, there's so much work we do, but sometimes every time you go back, there's no way you can even remember, even myself, how I did it and how I can even leverage it. And what happened, usually you ended up starting from scratch, something you've spent a year or two doing. So today it will be really about reproducibility and data sharing. I actually put those together because you're going to see why. Because for me, we are all talking about sharing data, but what are you sharing? Is that data really usable? Because the key is really in the usable aspect of it. So I'm going to start with a little bit of a preamble because the words really mean so many things to many people. I just wanted to first state the stage, and then I'm going to fast forward to understand where we are in that particular space and why this is very critical. And why I do believe if, let's say, CHPC South Africa can take the lead or also changing the culture, this is something that can also put them on the map. I'm just going to also introduce, I've been getting a lot of funding from the National Science Foundation to building platforms. So we just recently got funding for building this shared system. And again, like I said, for sharing secure data. And again, it's about accessibility and reusability. And then start now making it really happen. And then the last thing is, this is a journey I've been at for the last 2 years, is we talk about reuse, but it has to come from the community. Because if I'm a chemist, I'm a social scientist, I'm a humanity person. We don't have same skills. We don't do the same science. So what it means here does not mean the same thing over there. So it has to be driven by the community. So we are really launching a big initiative worldwide to build this community of practice. And you're going to see me how maybe we can be involved in it. So about a year ago, I actually started this. I always start with these 2 pages because this is something we've been actually doing quite a lot. Quite often you will do 1, 2, 3 years research and you publish results, and then you have some nice figures and results. But for me, those papers is not really, I like the quote of David, is not really the scholarship itself, is not really what constitutes the achievement, because sometimes it's like you are really kind of marketing. What is important to me is the data. You're going to hear me saying the word artifacts. What you're sharing that really can allow somebody to reuse or produce the result that is in that particular paper. Otherwise, the paper itself is really the advertisement of that scholarship itself. This is also something, this is an academic environment. Typically, you go do your PhD 5 years, on postdoc or 2 years. And in 5th year, usually that's where you're senior. And most of the time, I don't know if it was your case, your advisor usually does not even want to let you go because all the production, everything, yeah, the senior PhD is the one who knows everything. And typically, once that person graduates, in every group, is always there's a vacuum because I say, oh, we don't remember how to do this, and because John Doe left, he's the one who did it. Postdoc, the same thing. And this became home one time because at the center, I had the senior researcher went to NVIDIA, and he worked with us for almost 7 years. It was actually a model for us to document and share things. But when he left, even though we had access to all his folders, quite often it took us years to redo, even to even understand what he was doing. And you say, when I say a year, meaning you are wasting another year to reproduce something that was funded, something was completed. So basically, that's really where I said to myself, there's got to be a solution to this. At the same time, in 1990, I don't know if you follow the National Academies of Science, Engineering, and Medicine, really produced this report, and I would strongly encourage you to read it if you can, where they really kind of define some of these concepts and then kind of say the state of the reproducibility. And then you will see on the side here, because when I say reproducibility, but sometimes we recreate, recompute, all these words actually they have some subtlety to them. So I'm not going to go through all the differences, but for me what I'm kind of focusing is really the reproducibility, the reuse. And I want to also point out this is really critical for me. I am not talking about numerical reproducibility because that's a computer science problem. And I'm sure Intel folks will appreciate this because depending on the floating point operation, it's not sometimes always difficult. So let's put that aside. And for me, it's just simplifying this, okay? I just want to be, so okay, they say Dr. Sitolev finished his PhD and then independently cannot go back, took what he did, and then kind of reproduce those results that he did. Keep in mind the keyword independently. And that's for me how I define reproducibility. Now, flip it a little bit to data sharing, because when I say sharing data, we are generating a lot of data. So there's the data you are generating. There is the data you are doing for processing some results. You also have the data that you are doing with sharing associated with publication. When you look at the research data cycle, you know, we always start with acquiring some data, computing, storing, etc. And then we've been actually adding this box here, because for me, this box is the one that used to be missed. And then what does that mean at that point? You don't want to wait until the end of the year when your research is over to start packaging things. It's too late. You have to do it during the life cycle of your research. We just heard that nowadays some of these processes are so capable. So there's a lot actually they can be doing, capturing metadata processing as you go to make it so seamless. So the question to me is, the data that you're sharing, is it really reusable? And that's going to hear basically the theme. And then I'm going to tell you what we've been doing. I just want to throw out this again here, because a lot of the fact you say, okay, data sharing, we can do the Git repo or Git this website. No. In 2022, actually, the White House, they released a memo to all the federal agencies. It's going to be required, starting 2025, all the federal agency, meaning if you're getting a grant from NSF, NIH, any federal funding agency, at the end of that particular research, you need to share reproducible. And you can see here the mandate, which means it had to be shareable. Actually, NIH has been also even struggling to understand what does that mean to share HIPAA data, what does that mean to share data that is really restricted. That's why you are seeing all this buzz about secure environment. Security is becoming really, really key. And I can actually talk to you about things we've been actually pushing in that area for building this environment that to meet those requirements. This is something that all, like even in our center, we are really struggling to kind of be ready by next year because we don't want to use the funding agency. My center just got audited because PwC, they say, are you ready? They were trying to see our readiness because we don't want to really be caught off guard and not be able to support our faculty. Really big thing. So what I'm just saying is not like I'm just saying for the sake of I love that particular topic, but that's how we are moving. And by the way, we talk about AI, you just heard the privacy. A lot of things people don't know is there'll be a lot of collaborative work that are moving XYZ. Those platforms are going to be really, really key on how they meet all those standards. So just a little bit to say, I wear multiple hats. We heard I run a center that I created in 2013. We have about 3 megawatts of data that we have. This is just for the research that we support. But like any center like CSPC, you have the 3 pillars. We have the hardware and then software really big for us because that's where you enable the science. But the last pillar for me is the one that I care a lot about is how do we provide the human being? We have a team of computational scientists. These are the people who do the science to enable faculty and faculty project to do. And a lot of the data management and then reproducibility that we are trying to make available are really developed and done within that particular group. I added this thing for one purpose because I also want to make a stage. Today, and I think I heard this also CHPC probably, it can have a picture like this. When we talk about actually Langa, we think about usually the data center, the systems that inside the data center in Cape Town. In our case, is the one that I just showed you in Chicago in Hyde Park. Think of this box here is that basically what I just showed you. But research today, when I think about, for me, a faculty, is actually a combination of these 3 things here. We actually, by the way, we just released a secure data enclave where anything that is restricted is not in the same place where the open science data is. And then basically here there's all the security requirement. HIPAA is a HIPAA 800-171 compliant, which means sharing things mean different things over there than that. So this same researcher also has access to Argonne, has access to access resources, and then as well as in the cloud. For us, you research at Chicago, you actually don't need to learn anything about the cloud. Basically, you submit your job, you just say AWS, it takes provision, finish, come back, and then move back to your home directory. The same way you say, okay, you're sending to the local machine. In a case, let's say I'm sending to Langau, I send it AWS. Basically, the user make it that abstraction. So just in your back of your mind, when I talk about data sharing, think about this actually in the back of these 3 kind of ecosystem where the data management will really mean different things to different people. I'm not going to spend actually time. I was thinking, I wish actually I can also talk to you. We are working about some very cool project, in particular in AI. And the recent one I just got myself involved is about AI and climate. In most of the climate model, they run for months and days. So we are using physics-inspired AI for predicting extreme weather. And in particular, Florida, and in our case, there's a lot of hurricane. Yesterday was a great presentation about tropical cyclones. And then when you see about all the inundation things that are happening, this is really something that will have a great societal impact. And then to train some of these models, it takes a lot of computational resources. But this is happening. But the rewards from this is really, really something that will shorten the time to science and be able to do. So we have a lot of projects. These are projects for which I'm funded, and I have team will work on these things. But what I say here, we generate a lot of data, and then usually these are a team of people that will run, and then when they leave, like I was saying, just last year alone, I left to AWS and Azure. It's like we are training people go make 3 times the money we can pay our university. So we are like a training grant for them. But it's good. We are happy for them. But usually when they go they actually support us from those institutions where they are going. Oh, this one is another actually nice project we did. We dump all the books for high schools in trying to understand what we teach our kids, how it impacts about race and gender. A very, very nice piece of work that was even pictured in Washington Post. But training all the LLM, you can see how you can actually do some of these things. Now, when we say generating a lot of data, I just painted some of those projects to just tell you it's real, it's not something I'm making it up. And then we are all computational people. But I want to pause a little bit here to say, okay, we heard actually edge. But I think some of these edge systems are really humongous. They generate terabytes. This little light, you see this little machine here on a table. This one generates about sometimes 10 terabytes in just one experiment. It's in the little room in the office of a faculty. Had to be pushed, processed, and then and so forth. So in the age of AI and I think we want to keep as much as some of the data because sometimes we want to also come back and then train on them. We just bought a cryo, this is for cryo-EM, another system that really generates amount of data here is could reach up to the petabyte. And this is again a machine that is at a location near your data center. People go take the sample. This machine here is in Italy, in Gran Sasso, where the community basically pushed the data to Chicago, and we are the distributor for that particular research community. It was just an example of different experiments that are remote. In your case, you're going to have the SKA. I mean, imagine you have also Illumina. You can paint a similar picture like this. But back again, what I'm trying to say here, just keep again in the mind, what does that mean, data sharing? What does that mean when I'm going to start doing reproducibility? So the size of the data is going to also make a big difference, because it's one thing to say, I'm going to reproduce 1 petabyte of data, and then with like a 2 megabyte of data. So there's some differences. So back 6 years ago, the National Science Foundation funded me to kind of create a data management to make that seamless, to collect that from an instrument. But this year we got a new grant, actually a few months ago. We are now trying to move the platform to something we call a secure hub, because one of the things is the center we have is one space, but you have people like doing astronomy with the open science grid that say, okay, no, you want this to be integrated, interoperable, where you want to be able to move data without having basically hiding all the complexity of the trust between one system to another one. And then you also have the ability to say, okay, I completed the research, and you heard me, I was saying, when they do the artifact for reproducibility, usually at the end, I want to do it throughout the research cycle. So I wanted to have a platform where I can start storing all the reproducibility artifacts to do a proof of concept on my vision, where you say, okay, when you're capturing this, it's going to be seamless. So we are building this shared environment, and will be actually available in the beginning of next year. Basically, we're trying to make it seamless. In other words, I have an account. I'm just going to take an example of Langau. Imagine you have an account at Langau. You're doing a research, molecular dynamic, and etc. A year later, you finish. You basically type a command. It captures the reproducibility artifact. It deploys a container. It's kept in a registry somewhere, and basically that's what you're sharing. Basically, where all that's going to be happening, we are going to be piloting some of this on this shared environment. Now, I'm going to back again. I heard you, this is a share, but it's really a second funding from DALI. DALI was the one that was collecting data. So those two systems actually are built on top of each other. But when I think of my vision of data sharing, basically we are also going to have another platform. I'm calling it Data Hub. And then you're going to hear me why I'm going to explain this in a minute. Is when we talk about a repository, for me, the repository is going to be the thing of the past. Because usually you go to a repository, something that the library keep, and then you just basically it's frozen, and then you don't know what's in there. You pull out, and then that's what I use. My vision of repository of the future will be something that will be sitting in centers like CHPC, where, like I was talking about, is a registry of containers. But when you pull, there will be some intelligence to even assess, do I really need, if it's really the information that I'm trying to look, or if, let's say, I'm trying to do that, some correlation. It will do some work prior to you even opening or downloading the work for you. So there will be some computation behind this that basically will be what, for me, I envision to be that data hub of the future. And I'm going to come back again here. You heard me, this is like some cartoon, but as you can tell, probably I'm not good at but I was trying to think about the life of a researcher. So I remember when I was a graduate student, I would start do the work, and then, of course, I have an account to my university data center. And then you will do some results, and you try. And quite often, the first time you do something, you don't get the right result. You try another method, you try something else. And in my case, actually, for 2 years, at one time, we were trying to solve some indefinite sparse linear problem from NASA, and then we could not just get it. And then I had to change course. But 4 years down the road, I found out how to solve the problem I was having. But at that time, I had lost whatever the source code, whatever I've done, which means I couldn't even go back to doing the method I was trying to do. So there's a lot of also sometimes throughout that process, frustration, where sometimes you give up. And there was actually a time where I didn't want to say, well, it's been like 4 years, what am I doing wasting my time with this PhD? But you stuck with it, and then you continue. Now, and then you do new ideas, and then you publish, okay? And then you share your result. Now, why am I giving this example? Because sometimes we hear people say, oh, no, I can just share you a Jupyter notebook. For me, Jupyter notebook is just something that is very well structured, which means that at the end, you know already what you've done. But the real life, though, is people will try different things, and then actually at that time, maybe you had gone through a dozen of different Jupyter notebooks, but it's the last one that probably that worked. But for me, all that work, or the attempts, all of that are metadata information that can be useful for various reasons. So, and then at the end of your work, that's when, think about basically like in the graph theory, you had tried to go back basically to find that short path that led you to the final results. Maybe that's what you're capturing for sharing, but in reality, that's what I call the reproducibility artifact. But if we can keep all that work, there is a lot of intelligence, there is a lot of wealth in that back that can be basically usable. And then that's where actually, again, the question. I added this one also because we hear a lot fair principle, fair data. So what I'm talking about is really in this R, we call the R, the reuse. And then that's where, for me, I'm trying to say, okay, let's agree on what that means. Let's agree on what we are sharing here. Now, what are the questions? I mean, I touched some of these already. Can you reproduce? And then the second question, actually, do you have enough information you've collected that make it to be able to reproduce the result you're talking about? And then the idea of not going into the end. But one thing that also I want to say is the amount of work that somebody had to go through to put that together at the end, you finish your research, there's no motivation at that point to do it. Yeah, so that's why for me, that if it can be seamless, that's the only way the graduate students can do that. We ran an experiment at Chicago, and the graduate students were forced to produce the artifact that they published. All of them were very unhappy. Run an anonymous survey. There were two major reasons why they were very unhappy. Of course, one of them, they could not lie to their advisor, because sometimes every time they present something to their advisor, they know the advisor is not going to check the results. But then the other reason, which was a legitimate one, was when you finish your career, that's your secret, going to build your career on that work you've done. But if you share it, then it's up to the public. You don't have anything to hang on. So, but that one, I think, can be addressable by protecting the information that belongs to you. And then just quickly, also to acknowledge, there is a lot of work. People are attempting to do different things, from repository that I indicated, to encapsulation tools, all the way to provenance. All those are really useful, but they address only one aspect of the problem. And like I say, you can go to Zenodo today, you download even 10, 20 artifacts, try to reproduce that. And then that's how you can see why the problem I'm talking about. I also want to acknowledge here in recent years, there have been also ACM just created a new conference on reproducibility that actually are inviting people who are doing some of the research work along those lines to make this idea a dream that is now actually being, is in its second year, and next year actually is going to be in Vancouver. And then also one thing I also want to point out, supercomputing is now requiring, when you submit a paper, you have to put reproducibility artifact. As a matter of fact, they have a badge system, which means when you put the artifact, you get the first badge. If, let's say, your artifact has some documentation, there's another badge. If now they can take that artifact and then reproduce it, you get the third badge. I would like to challenge my colleague at CSPC, if we can be also the next one at next year, start encouraging our researcher, present our poster, to be able to start actually changing the culture, because that's what the requirement things are going. That would be really a good thing, because you can also contribute to the community on how. There was a big meeting last year at supercomputing on some of the lessons learned, but it's again, like I say, a community of practice that's going to make this refined. And then these test beds, by the way, are test beds that basically they are providing access to be able to check if it's reproducible or not. Now, the question is, like I say, all these initiatives are not, in my view, sufficient to address this question. And then some of the observation, like I said, is the paper themselves is that they don't capture the whole workflow. It's usually you are kind of focusing on the end product, but you forget to capture what you did to generate those results. And then, like I indicated, also some of these data are so large that if you look at a lot of the library, it's usually like the PDF or megabyte, or rarely more than a gigabyte that can allow you to do the reproducibility. So for the last 4 years, what has been my approach, actually, one that I've been kind of pushing, is more a three-legged tool. So I think for me, there's an aspect where we need to create tools that will make this capturing seamless. And the two, like I indicate, the repository for me of the future is a concept that has to change. And last, education and training. When I say education and training, we talk about Git, we talk about containers, but these are concepts that not everybody is familiar. The same way we learn English 101 or calculus, it seems to me some of these had to be what to learn at the beginning when you start your graduate school. So those are three things for me that have to work hand in hand to be able to make this vision a reality. So what I've done actually in mind, my vision I'm trying to create will be, I call it Data Hub, and then we are actually training, creating some educational tools with the community to create something like a reproducibility carpentry of some sort. And then the tools is the part that I think for me, I kind of take back the last 3 years. We've been actually developing some tools, and we are hoping sometimes we're going to make them open source so that people can see what we are talking about here. In terms of the tool that I've been focusing on for me is really, like I say, you have an account on Langau, how you automatically behind the scene as a middle layer software, capture automatically the metadata, all those workflow, the packaging, the minting of DOI, all those will be basically seamless to the end user. And we've done already some proof of concept to this. One of the proof of concept, I took one, which is a big group at Chicago, Professor Greg Wolf, that did, one of his graduate students, this is a journal that was published, that we kind of tracked him for a year. And then we're trying to see at the end, can we use all those tools for molecular dynamics? And then this is why I was convinced this is not just doing on Mickey Mouse a synthetic problem, because that's what we were doing before. So it's real. So we did create a Data Hub 1.0. If you go there, you can see a little bit of an idea of how we capture some of these pieces associated with the results. Some of them also we have some of the Jupyter. You can also run from the portal. And this was done also some of the work with Argon. But that's when I realized the amount of work to capture that was just too much for to expect that's going to be scalable and sustainable. And that's why we are trying to develop a 2.0 version where we integrate these tools and we make it seamless, basically lower the barrier, and then to make it portable. So in a nutshell, we really need to rethink our platform. For me, I think when we do an RFP to get a system, that's where we're going to have to ask from the OEMs. We need a system that will come also integrated, that will provide those functionality. We need to rethink how we conduct our research and then develop the training. So for the last also supercomputing, there's another big conference called PERC, used to be Exceed, that we've been having a lot of gathering. This is one of them, where we are trying to build what we call the community of practice, where basically you have to be discipline specific. In other words, it can't be pushed from the top. So what we are thinking, like all the chemists, all the material science can come as self-organized, because that's how you're going to drive all those requirements. That's how actually the federal agency will be able to understand what does that mean. Because NSF and NIH can impose something, but if it's not driven by the communities, no work. So this is gonna, I think I'm excited about this. This is something me and 3 other universities we are leading. We're gonna create in the US what we call a reproducible community of practice. The idea is not to wait just supercomputing at the end, but to organize a series of activities where we're gonna be presenting all the achievement. This is where you're gonna fund actually all the tools. This is where we're gonna make it basically accessible. Everything that we're gonna make available, the webinar or the presentation, they're all gonna be around here. And then we're gonna create some working groups that we're gonna become the one that are gonna focus on the different aspects of what will be. So this is, I think, for me, when I was talking to NSL, they say, if we can achieve to build that community, I think that's what actually we're gonna also funding. So, and again, the reason actually I chose to talk about this instead of my research, because I believe there is a stand here for a partner with CHPC. How can we also drive the same thing on the continent so that at least we can lead on where I see a topic that is of great importance. So this is just a QR to people if you want to be on the mailing list to receive. So a lot of the Zoom is going to be something you can attend from wherever you are. Then at least you can remain. So if you can go to the website and be added on the mailing list. So the website is still in development, but at least people can participate also remotely. So I'm going to end here, and I'm just going to acknowledge a lot of the funding from the National Science Foundation, and then many of the things are presented here. There is a lot of my team member in the back that really a great team of people, and some of my partner from University of San Diego and Minnesota and other places that we've been kind of working together on this. So thank you so much. This is again my email address, and it's always a great pleasure to be here, and I very much appreciate the opportunity.
Another round of applause for Prof. Birali. Thank you so much, Prof.
Yeah.
And I think we had a discussion yesterday to say, you know, as NICIS and you know, some of the institutions that you represent, including the University of Chicago, how can we begin to collaborate? And for me, this is the reason why we have some of these, you know, platforms. We're not just here to talk about the research, but it's also about creating that community of practice. So from our side, from NICIS, we are committed, and we are hoping that we can do greater things together. Any pressing questions, colleagues, for Prof. Birali? If there are no questions, let's use the opportunities, whether during tea, as well as throughout the day, to engage. Thank you so much, Prof.
Thank you. Thank you.
Ladies and gentlemen, thank you so much for attending our keynote. I see, you know, as time went on, you know, the numbers began to increase. This is not the end of the day. There are breakaway sessions, and also downstairs, for some of you who might not know, we have student competitions, you know, that are happening as we speak. So if you have a chance, please do make a turn and go and support our students. Thank you so much.
I think he wants a picture.